Alright, welcome back everybody. In this video we're going to look at how we read stem and leaf plots. We start with a basic definition of what a stem and leaf plot is and an example of what one looks like. Basically, a stem and leaf plot is just a method for us to organize and display data so that we don't have to write out each individual data value. We kind of group data values under a stem, and it allows us to represent a lot of data values without as much writing. When we create a stem and leaf plot, the data is normally listed in ascending order from smallest to biggest, and you see here the stems go from smallest to biggest vertically, and the leaves go from smallest to biggest horizontally next to their stem. Every stem and leaf plot that you see should have some kind of key or legend to indicate what numbers are represented in the stem and leaf plot, and you can see my key down here for this particular stem and leaf plot says that 3 as a stem and 4 as a leaf means that the data point 34 is in our data set. And so we've represented a fairly long list of data here. I think it's about 20 values, 21 values in this particular data set, and all this does is it represents the data set 20, 21, 21, 22, 24, 25, 26, 26, 26, 31, 32, 34, 34, 36, 38, 39, 40, 43, 44, 48, 48. And that's a long list of data that we encapsulated in a relatively small stem and leaf plot. Alright, now we can gather information from a stem and leaf plot just like we can from a list of data, and that's just what we're going to do in this first example. We're going to find all of this information from this stem and leaf plot to get you acclimated with how to read and use stem and leaf plots. Alright, so let's start with the mean. First of all, I can count up the number of leaves in the stem and leaf plot, and that is the number of data values that we have in this set. So if I count all of those up, I've got 9 leaves under the stem 2, I've got 7 leaves under the stem 3, and 5 leaves under the stem 4. So 9 and 7 and 5 makes 21 total data points in here. And now I need to add up all the data points. And I have a method that I use for doing this. I'm sure other people use this same method, but every leaf that appears underneath the stem 2 starts with a 20. So instead of typing in 20 plus 21 plus 21 plus 22, I'm saving myself a couple keystrokes. There are 9 numbers that are in the 20s, so I'm going to take 20 times 9. And then I'm going to add all those leaves in at the end. In the 30s, there are 7 numbers that show up in the 30s, so I'm going to take what that stem represents and multiply it by 7. And there are 5 leaves in the 40s, so I'm going to take 40 and multiply that by 5. And then I'm going to add in each of the individual leaves. And this cut down a little bit on the amount of typing that I needed to do from if I just typed in each data point individually. And we find that the total amount of that data set is 678. And now I'm going to take that and divide it by 21, and that's going to give me my mean for this data set, 32.29. Stop and ask yourself, does that seem like a reasonable mean? Because that can help us if we make a calculation error. But really, you've got to be careful, and as you're typing numbers in, make sure that you get every one of the data values in there for the mean calculation. Alright, now for the median, we're looking for the middle number in the list, and the list is in order from smallest to biggest. So I'm going to move in from the ends. Those two numbers pair up as the smallest and biggest number in the set. I'm going to keep pairing up numbers that way. And now that I'm done with the 40s, I'm going to move to the right end of the 30s. And now that I'm done with the 20s, I'm going to move to the left end, and we get to here, and that 2 right there represents the median. So it's got a stem of 3 and a leaf of 2, so the median is 32. Oops. Typo, Thomas. Part C should be asking for the mode, the most common data point. If we look at this, we see that the value 6 appears 3 times underneath the stem 2. That's the most leaves that occur for any particular stem. That's going to be our mode. So it's going to be 26. First quartile, we're going to look at all the numbers below the median. So since the median was exactly at that 2, we're looking at all these numbers that I've highlighted in pink. And we're going to count in towards the middle of those to get our first quartile. And the first quartile is between the leaves of 4 and 5 underneath stem 2. So halfway in between those is 4.5 with a stem of 2. That makes our first quartile 24.5. Our third quartile, we're going to go to the other end. We'll do the numbers here that I'm going to highlight in orange. We want the middle number from that group. And the middle number from that group falls in between the 9 here and the 0 here, so it's between 39 and 40. Makes our third quartile 39.5. To get our IQR, we're going to just go ahead and subtract third quartile minus first quartile. Gives us 15. The minimum is the smallest leaf at the smallest stem. So we've got a leaf of 0 with a stem of 2. So the minimum in this data set is 20. The maximum is the biggest leaf for the biggest stem. And so we've got a leaf of 4 with a stem of, a leaf of 8 with a stem of 4. Makes the maximum 48. And then the range of the data set, we go back to that, is just maximum minus minimum. That's going to be 28. And that's how we can find all of our data characteristics that we've talked about thus far from a stem and leaf plot. All right, let's look at the next example and see what this one has to say. Gabriel randomly selected 20 cars in a parking lot in his city and determined each car's year of manufacture. He made the stem and leaf plot below to show the results. First question, what are the lower and upper quartiles of the data? So the first quartile and the third quartile of the data. And in order to find this, we first need to figure out where the median lies. So I'm going to count in towards the middle. And it's in between this 9 and this 0, so between 2009 and 2010. So we'll say Q1 is equal to 2009.5. And quartile 3, oh, I'm sorry, that was the median that I just found. Now to find the quartiles, I need to go for the median of the numbers below and the numbers above. So the median was right here. And so for the first quartile, I'm going to look at all of these yellow highlighted values, and I'm going to count in towards the middle of those. Oops. Geez, I'm really messing this one up. I neglected to include, my median was to the right of 9. So 9 is in the list of numbers that we're looking at. And so we're going to count those in. 1, 2, 3, 4, 5, 6, 7, 8. And so quartile 1 is going to be in between 2004 and 2006. So halfway in between those. Quartile 1 is going to be 2005. All right. And for the upper quartile, I'm looking at all the numbers above the median, and I'll count my way in towards the middle of those. Bam, 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 Bam. And so quartile 3 falls right here in between 2013 and 2014. So we're going to say 2013.5, halfway in between 2013 and 2014. All right, now for these last two questions, we're going to use the information that's given in blue here. It says, suppose that there are 10,000 cars in all of Gabriel City. So we're going to predict some information about that based off of what he saw in this parking lot. Question B, how many cars in Gabriel City would you expect were manufactured between the 2 years in your answer to part A? Now, my answer to part A were quartiles 1 and quartile 3. And in between the two quartiles, 50% of the data should occur. We talked about that a while back in a previous video about quartiles. So in between those two, 50% of the data value should occur. And so if we're going to make a prediction like this, we're going to say that 50% of the data is in between those quartiles. So we're going to take 0.5, which is equivalent to 50%, and multiply it by the number of cars in Gabriel City. And we're going to expect that there are 5,000 cars that were manufactured between the year 2005 and the year, quote-unquote, 2013.5. So about 5,000 cars in his city are in between those 2 years of manufacture. Part C. How many cars in Gabriel City would you expect were manufactured in 2015 or later? And in order to see this, I'm going to clear off all this information from my stem and leaf plot. And we're going to look at Gabriel's data set and find the probability that there was a car that was manufactured in 2015 or later. And so we identify all the leaves that represent 2015 or later. There are 4 of them out of the 20 cars that Gabriel looked at. So the probability, based on Gabriel's sample, that a car would be manufactured in 2015 or later is 4 out of 20. We're going to take that and multiply it by the 10,000 cars that there are in Gabriel City. And we'll do the arithmetic. And if we do the arithmetic on this, we end up with 2,000. So we would expect that roughly 2,000 cars in Gabriel City have been manufactured in the year 2015 or later. So that's how we can read stem and leaf plots, use them to find data values about a data set, and use them to answer some questions, and even make some predictions using probability and the information that we have in order to see how likely it is that a specific outcome occurs. All right, that's the end of this video. See you guys next time. Have a great rest of your day.